Hi class, this is the Introduction to Truth Tables video, and more generally what we're starting to do is to learn what all of these operators do, what inferences can they make, what do they mean in terms of logic, uh, what is entailed by my view, etc., etc. And so once we learn to start to answer those kind of questions, it's a very powerful combination with what we learned in chapter 1, that we can learn what someone is saying, but also what is entailed by what they're saying, etc. And so the very first step in that, and what we're going to, is the topic of chapter 2, which is truth tables. First and most generally, I wish the authors had spent a little more time on focusing on big picture, what is a truth table. You can think of a truth table as a presentation of all possibilities. That's all it is. It's just a very graphic list of all possibilities in terms of truth and falsity. And so notice all is a generic word because truth tables could have anywhere between 2 and sky's the limit lines. But that's what it is, a presentation of all possibilities. And how many possibilities is determined by how many different things can be true and false. If only one thing can be true or false, think of it like a coin flip. If somebody was presenting the possibilities, how many would there be? 2. However, if there are 2 different things that could be true or false, think of it like flipping 2 coins. How many possibilities are there? 4. Heads, 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 tails, tails, heads, tails, tails. And if we increase to 3 things that could be true or false, it goes up to 8 lines. Because what we're ultimately doing, the number of lines on a truth table will always be 2 to the n power, where n is the number of distinct propositions. And I want to emphasize the word distinct there. Looking forward a little bit, if I have something that's A and B, or not A, sorry, how many distinct propositions is that? What's our n? Just 2. So we have A's and we have B's. So even though even though A occurs twice, there is only 2n, which leads to 4 possibilities. Why? Because remember, a truth table is a list of all possibilities, and there's simply no possibility of A being different than A. So there's no line in which A is both true and false. That is impossible. So we take 2 to the n. If you're not good with exponents, that means the possibilities for truth tables are 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. You'll never, ever, ever do anything that long. I feel like even 16-liners are kind of spite. 8's usually a pretty good number because, as a general principle, it's like reading a book. If you can read a paragraph, you could read a page. If you could do an 8-line truth table, you could theoretically do the 16 if you were so inclined. So in general, when we're practicing exercises and things like that, don't you might get a 16-liner every once in a while, but as a general rule, just if you feel like you're up to an 8, you're in pretty good shape. So that's how we generate the number of lines in a truth table. And when we, having said that, the the first step is the number of lines, but then we actually have to do the operations. And so, like the previous chapter, Ulrich and Gustafsson are going to introduce just 3 operators for now. And these are things you just have to know like the back of your hand. And it's one of those things you really need to practice, because if you even have to stop and think about these during the exam, you're going to run out of time. But these are all on page 39, and these are the truth tables for operators. So truth tables for operators. And of course we're doing and, or, and not. So, quite simply, combine what I already set up here. Well, and always conjoins 2 things. Call it P and Q. So, how many possibilities are there for P and Q? Well, what's our N? Our N is 2. So our number of truth table lines is 4, and for reasons we will talk about later, we go TTFF, TFTF. Those are, sorry, that's a T. Those are all 4 possibilities, just like heads, tails, heads, tails. So because and conjoins 2 things, we should expect 4 line truth table. And it mimics ordinary language. So this is something we talked about in the last chapter. Well, think of something that's true and something else that's true. Mickey is over 6 feet tall and Mickey is bald. Well, that's true. However, think of something that's obviously true. Mickey is over 6 feet tall, and something that's obviously false. Mickey is over 6 feet tall and slender. Well, that's certainly false. What about something different that's false? Mickey is a psychologist and he's bald. Well, that's false. Mickey is a psychologist and he's slender. That's false. And so when we have a conjunction, you will notice the only time that it's true is true and true. But what if instead we said P or Q? Well, once more, we have 2 things here. And so we should have a 4-line truth table. And again, for reasons we'll talk about in a bit, it goes true, true, false, false, true, false, true, false. So what happens here, again, if we mimic ordinary language and we remember that this is an inclusive or, which means both makes it true, is it true that Mickey is over 6 feet tall or bald? Sure it is. Is it true that Mickey is over 6 feet tall or slender? Sure it is. Is it true that Mickey is a psychologist or he's bald? Sure it is. Is it true that Mickey's a psychologist or slender? No, it is not. And so in this case, that's what the truth table for the or operator always looks like. And you'll notice, I like to think of them in terms of this one is only true when both are true. This one is only false when both are false. That's a way to start remembering it, but it's also a key way when you start actually doing truth tables for propositions. And you have to present a whole bunch of possibilities, say on a 16-line truth table. That lets you go really quickly through the computations. Not P. Well, what's our N here? We only have one thing. And so that requires 2 to the first power, which means we have a 2-line truth table, which means P is true or false. Well, take something as true and negate it. Mickey is over 6 feet tall. That's true. What about the statement Mickey is not over 6 feet tall? That's false. Take something false. Mickey is slender. Take not false. Mickey is not slender. That's true. And so when I'm doing kind of my fast forward version of truth tables and I want to remember quickly, and is only true when both are true, or is only false when both are false, and the negation just flips the sign. Whatever it started as, you got to flip it to its opposite. So that's for operators. Now, if you're paying close attention, you will notice that I am using lowercase letters. Why? Because P can be anything. And as we're going to see, we can do more complex computations. And we're going to skip right to that. So we're going to start on a new page. By the way, if you have some around, graph paper is wonderful for truth tables. I just don't happen to have any, and I don't feel like going to the store in the pandemic. So Ulrich Gustafsson walk you through kind of really slowly using a lot of lines. I'm going to show you how to do kind of the compressed version. The compressed version just put a single letter or a parenthesis. I just lost focus because of my hand. Under on each line. So let's say I was trying to compute the truth table. A, or it is not the case that B and C. Okay? So remember, a truth table is a presentation of all possibilities. So how many possibilities are there? Go back to our previous page. The number of possibilities is always 2 to the n. So my first question, what's my n? How many distinct letters do I have here? Well, to keep it simple, I gave you an A, a B, and a C. So our n is 3. 2 to the third power is 8. Now, here's how I do it. Some people like to do the doubling method. Some people like to do the halving method. Your textbook authors, I think, do the halving method, which is the right way to go because it has a built-in double check. What do I mean by the halving method? As soon as I figure out the number of lines, I half it. What's half of 8? 4. And so my first letter, I'm going to go 1, 2, 3, 4 true, and 1, 2, 3, 4 false. I might even put a little dot there since I'm too lazy to get graph paper. Then I half it again. So for the next letter, I'm going to go half. So what's half of 4? 2. So I'm going to go true, true, false, false, true, true, false, false. Then I'm going to half it again. And so for the last one, I go true, false, true, false, true, false, true, false. Again, sorry for the not quite straight lines. I'll try to neaten it up as we finish the computation. But first of all, here's the nice thing about the halving method. The reason it has a built-in double check is by the time you're by ones, true, false, true, false, true, false, you should be out of letters. And if you're not out of letters, you've done something wrong. So that's how we set up the truth table. This represents all 8 possibilities. You want to do it by a method instead of just trying to think of all 8 possibilities, because again, think of what you're going to do on a 16 line or 32 line. It's just not worth it. So just nice, straightforward halving method, built-in double check. So again, what did I do? Calculated my n, which is 3. 2 to the third power is 8. 2 times 2 times 2. Then I half it for the first letter, and I go 4 true, 4 false. I half that again for the second letter, so I go 2, 2, 2, 2. And then I half that again for the third letter, and I know I'm done because it's by ones. All right. That is the assignment of all possibilities. let me give you the order of this. Just like in mathematics, there's an order of operations, and you must do it in this order. So, what's the order? You got, once more, this is something you got to know like the back of your hand. First, we do atomic statements. That's what we just did. Then we do negation of atomic statements. Then we do parentheses. Then we do negation of parentheses. Then we do brackets. Then we do negation of brackets. Then we do sets. And then we do negation of sets. So obviously not everyone has all of these. Wherever you run out of next steps, that's when you've reached your main operator. So, to do the atomic statements is just to assign all possibilities, which we just did. So let's do step 2. Are there any negations of atomic statements? Well, let's see. What is this negating? It's not negating an atomic statement. That's not negating B. That's negating the value of the parentheses. That it's negating the conjunction. So, since there are no negations of atomic statements, I move on to do parentheses. All right. Now here's where we need to use our conjunction truth table from the previous page. Remember, P and Q looks like this. The only reason it's taking this long for me is because I must write quickly. It's, again, something you must know like the back of your hand. Conjunction is only true when they're both true. So let's do some computation. This conjunction is conjoining what? It's always helpful to articulate that. It's conjoining the value of B and the value of C. So, when B and C is true, I go to my truth table. I'm on line 1. True and true is true. Next line, true and false. I go to my truth table. True and false is false. Next one, false and true. I go to my truth table. That's false. False and false. I go to my truth table. That's false. Or, once you're in the hurry-up mode, you remember, oh, conjunctions are only true when they're both true, so I could go true, false, false, false. Again, feel free to do that on your own a little later. And so what have I done? This column represents all possible values of the parentheses. We just computed the parentheses. Now what? Negation of parentheses. All right, let me say something in truth tables. You will only ever use each value once, or you're doing it wrong. So, kind of a good rookie start if you're just getting practice at these. Get yourself a highlighter or a marker, and you can just highlight them when you're done. I did that column, so I'm never using it again. I did that column, I'm never using it again. So then we go on to negation of parentheses. Do I have any of those? I sure do. What is this negating? Again, it's not negating B, it's negating the value of the parentheses. That is, it's negating this column, the one we just computed. So what does negation do? Remember, not P. It flips the sign. If it was true, it's flipped to false. So I'm negating this column, and I'm writing it right here. Not true is false. Not false is true. Not false is true. Not false is true. Not true is false. Not false is true. Not false is true. Not false is true. And once more, the rookie method, I've used that column. I have negated it. You will not use it again. Okay. Do I have any brackets? No, which means what is left? As soon as I run out of stuff on this list, that means that it's time for the main operator. In this case, main operator must be a wedge. Notice if you do it in the right order, whatever you compute last is the main operator. That's why I mentioned in the chapter 1 that you don't really need to spend a ton of time on main operators, because once you get good at truth tables, you'll kind of find them by default. So what's the main operator of this statement? It's a wedge. What is it disjoining? A and the negation of this value. So it's negating this column and this column. What's the wedge truth table look like? Again, something you'll need to know like the back of your hand later. Sorry for the crowded work area, but I just want to get it all on one page. You will recall the wedge is true as long as it's not both false. So if at least one is true, it's true. So for instance, line 1 is true or false, where at line 2 of the wedge truth table, it's true. True or true, where at line 1 of the wedge truth table, it's true. True or true is true. True or true is true. False or false is false. False or true is true. False or true is true. False or true is true. Again, rookie method, I'm going to highlight those two. And what is left? This is the main operator. What does that mean? That is the representation of all possibilities of that statement. Whatever that statement is, if, for instance, A is true, and B is false, and C is false, the whole statement is true. Just to give myself a headache, we could go back to the ones, well, what if I said Mickey is over 6 feet tall, or it is not the case that he is a slender psychologist? That statement's true. Might sound a little weird, but it's true. And so this is all possibilities. If A is false, and B is false, and C is false, the whole statement is true. Sorry, a little while ago I should have said he's not a slender psychologist. So, anyway, that's what a truth table does. Now, that's just computing the truth table. But there are some things we can learn about these statements. A single statement is either tautologous, self-contradictory, and notice on the review sheet these are required terms, or contingent. Ulrich Gustafsson don't put a whole lot of weight on contingent, but basically anything that's not one or the other is the third. So these are the only 3 possibilities for a single truth table. We'll learn some more terminology for comparing truth tables later. So, what does tautologous mean? A tautologous statement is always true. It's logically true. It cannot be false. So any of those 3 is a good way of stating tautologous. I like to use the last. Why? Because remember, truth table is a presentation of all possibilities. I like to put the definitions in terms of possibility. So a tautologous statement is when it's impossible that it's false. Is this statement tautologous? No, because it's possible that it's false. There's a line in which it is false. This statement is false when A is true. Sorry, A is false, B is true, and C is true. We've just demonstrated that. So because of this, we know this statement is not tautologous. It is possibly false. Self-contradictory is the opposite of tautologous. Self-contradictory means it's impossible that it's true. So what would that look like? All false. But look, it's possible that this is true. Line 1 proves that. And so this, if it's not tautologous and it's not self-contradictory, it's contingent. So contingent means possibly true and possibly false. Most statements you encounter in life are contingent. Notice the instructions in the book say identify as tautologous, self-contradictory, or neither. Please amend those to tautologous, self-contradictory, or contingent. Second thing I want to say, I've given the definitions, but if you want, I'll also give you the checks. What is the method I use to determine? Tautologous, the method. Check whether all possible values are true under the main operator. If yes, it's tautologous. If no, it's not. Self-contradictory, check if all possible values under the main operator are false. If yes, it's self-contradictory. If no, it's not. Contingent, look at all possible values under the main operator. If there is at least one t and at least one f, it's contingent. So this statement is contingent. Don't do all the work and then not write your answer. So that was a lot. I do want to turn you loose to practice these on your own, but I'm going to do just a few more. I'm going to use this one. We're going to go A or not A, and B and not B. And to make that well formed, we're going to do that. There's a statement. Looks kind of weird. But let's do the truth table to determine if it's tautologous, self-contradictory, or contingent. And we're going to use the same steps as always. You will basically never need anything besides this. That's why I'm doing it on the same page. So first we assign the values of atomic statements. How do we do that? 2 to the n. What's our n? Careful. Even though there's 1, 2, 3, 4 letters, there's only 2 distinct letters. So our n is 2. And so our total number of lines is 4, and I'm going to do the halving method. And here's where it's important to be careful. By the halving method, I go half is 2. So for all cases of A, I'm going to go true, true, false, false, which means doing it here and here. Again, sorry for the lack of graph paper. Then I'm going to half it again. What's half of 2? 1. So B goes true, false, false. For all instances of B, true, false, false. And I know I've done the correct number of lines because by the time I'm at my last distinct letter, I'm going by ones. Okay, that's step 1. Step 2, negation of atomic statements. Let's see, is this negation 1? Yes! What does negation do? It flips the sign. True becomes false, false becomes true. And I'm never using that line again. And here's another one. It's negating B. True becomes false, false becomes true. And I'm never using that line again. And it's worth articulating why. What does this column represent? All possible values of not A. All right, we've done negation of atomic statements. Now it's time for parentheses. Oh, here's some. What's left in this parentheses? You could think of this wedge as kind of the main operator of this parentheses. This parentheses, we get the value by disjoining A or not A. So what does disjunction do? It's true unless false and false. So true or false is true or false is true, false or true is true, false or true is true. We will never use this again, and we'll never use that again. This represents all possible values of the parentheses. Notice if we just stopped here, that would be a tautology. It is impossible for A or not A to be false. Cool. But now we have another set of parentheses. You could, again, kind of think of this as the main operator of the parentheses as a conjunction. Oh, I'm sorry. I told you I'd do that a lot. I've been using dots instead of ampersands. So we can think of this ampersand as the main operator of the parentheses. What's its conjoining? Not B and B, but B and not B. So this column and this column. And when we go to the and truth table, we know that it's true. It's only true when both are true. So true and false is false. False and true is false. True and false is false. False and true is false. Never using this column again. Never using this column again. And again, notice if the problem was just this, B and not B would be self-contradictory. It's impossible that it's true. But we've done parentheses. Are there any negations of parentheses? No. Are there any brackets? No, which means whatever is left is time for the main operator. The main operator is a conjunction. What is it conjoining? It's conjoining the value of these parentheses in the value of these parentheses, i.e. this column and this column. And it's conjunction, so once more, it's only true when both are true. So true and false is false. 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 Done with this, and if I didn't screw up, my one and only remaining column is the main operator. I don't usually use a highlighter, but I habitually circle the main operator. So this is all possibilities of this statement. Notice, all are false, and so this statement is self-contradictory. Don't put contradictory, put self-contradictory. Contradictory is something different. And again, don't do all the work and then fail to provide the answer. So those are what truth tables are and how we do truth tables for individual statements. I'm going to turn you loose at that for now. Our next video is going to be some truth tables for propositions, just more practice, and we might do a couple of different sets of instructions, but you should have enough to get a very good start. We will see you next time.